Alright, this is lesson 2.5a. It's a little add-on lesson to lesson 2.5. And what we're going to do is look at some absolute value inequalities. So the learning target for you is that you'll be able to solve absolute value inequalities. Now remember, we've looked at two different ways to graph functions and find their solutions. We either set it equal to 0 and figured out where they cross the x-axis, or in the inequalities figured out where they lie below or above. Or the other way to solve using the graphing method was something called the Intersect Method. And that is that you take two different functions and figure out where they cross. And that's what we're going to do in this example, is we're going to take these two functions, and rather than set it equal to 0, we're going to graph each side by itself or separately. So I'm going to graph this function, absolute value of x to the fourth plus 2x squared minus x plus 2. Then I'm going to graph this function, and instead of figuring out where they're equal, I'm going to figure out where one is less than the other. In other words, where this function on the left is below or less than this function on the right. So again, we're going to use the Geogebra graphing tool. So I'm going to go there and save a little time and have it already set up. So I've already entered the functions. This is the function that was on the left-hand side that was less than or equal to this function on the right-hand side. And what you can see on the graph is there's nothing there. It's because if I want the graphs to appear or disappear, I can just click on this little dot. You can see that the absolute value of x to the fourth plus 2x squared minus x plus 2 is this curve, and then 11x is this line. You can also see that they cross here and somewhere up here, so I'm going to zoom out a little bit so I can see it a little bit better. Notice that they cross here and here, and that those intersection points lie between 0 and 5 on the x-axis. So the input, or the command that you put into the calculator to figure out where they cross or intersect, is intersect. Okay, then you're going to put a set of parentheses, and you just want to know where function f crosses function g, so you put fg. Now I'm going to put also a parameter on there that says I want to only look between 0 and 5, and then hit enter. And by setting that parameter, the graphing calculator will look only between 0 and 5, and it finds 2 points where these two functions cross. One of the points is at 0.17, and the other point is at 1.92. That's 1.7 on the x-axis up to 1.88, and almost 2 all the way up to 21 point something. Now, recall that the inequality was that this function had to be less than this function. This function was the curvy one, and this one was the line. So what I want to know is, where is it that the curvy one is below the line, and that would be from here to here. And those points where they cross were at 0.17 and 1.92. So I can write an inequality that says my solution is all the x values that are between 0.17 and 1.92. And I think earlier I said that it was equal to, it looks like it's just strictly less than. So I'm looking at all of the points that lie between 0.17 and 1.92. That's my solution. And again, I found that by graphing this side and this side, figuring out where they cross, and then looking at where one graph is below the other. Okay, here's another example. Now this one, I could use the intersection method, or I can use the intercept method. And in fact, this question asks you to use the intercept method. That's the method that you figure out where it crosses the x-axis or the x-intercepts. So to do that, I have to get this equal to 0. So I subtract 3 from both sides. I get absolute value of x plus 4 over x minus 2 minus 3 is greater than 0. And what this inequality says is I want to know where this function is greater than 0 or above the x-axis, all the stuff up here. Okay, you also need to notice that this x minus 2 that's on the bottom of this fraction, there's a value in here that's undefined, and that is when x equals 2, 2 minus 2 is 0. You can't have some function over 0 that's undefined. And you'll see that in just a second when we graph it. So we're going to put both of those functions, or we're going to put that one function in and graph it. F of x equals, now to get absolute value with this graphing calculator, you just type in ABS, and that gives you the absolute value function. Hit parentheses, and then you can see the absolute value bars appear. We're going to put the top part of the function in parentheses, x plus 4, and that's divided by x minus 2, and then outside the absolute value it's going to be minus 3. Enter. Now what you notice is this function stays below the x-axis, comes up, and goes straight up, and then comes straight back down. Now this line, this part in between here where it goes straight up and comes back down, this is where x equals 2 is at, and that's where that number that's undefined. So this graph actually goes higher and higher and higher, but never actually gets to the value x equals 2. So we need to figure out where this graph crosses the x-axis. Those are called the roots of f. And that takes place at 0.5 and 5. 0.5 and 5. So let's just make a little sketch so we can figure out what's going on here. There's a graph. It comes up like this and down like this, and it crosses at 1/2 and at 5. We're trying to figure out where this graph is above 0 or greater than 0. So it's above 0 when x is greater than 1/2. And actually I wrote that wrong. When x is greater than 1/2. Okay, so it starts at 1/2, and it's above, and it keeps getting higher and higher and higher, but it can never get to the value of 2 because that value is undefined, so it has to be less than 2. So one of my answers is this graph is above the x-axis greater than 0 when x is between 1/2 and 2. But it also is above the graph when it starts to get bigger than 2 all the way up till it gets to 5. So my other answer is that x has to be bigger than 2 but less than 5, because once it hits 5 it goes below the x-axis. And those are my solutions. Alright, that's the graphical way to solve absolute value inequalities. We're going to take a look at the algebraic way. And this is something that you should have learned in Algebra 1. When you have an absolute value inequality that is less than or equal to some number, then really because you have the absolute value, you have two cases. And that is x could be less than or equal to 1, and at the same time greater than or equal to the negative value, -1. Now on a number line, what that looks like is here's -1, here's +1. The values of x can be between -1 and +1. This is an example of an AND inequality, or what we sometimes call between, because the values for this absolute value inequality end up being between two numbers. If you have an absolute value that's greater than or equal to, then what you do is you set up two cases. X is greater than or equal to 1, and less than or equal to negative 1. The problem is, if you write it like this, this doesn't make sense, because the value x, if I put it on a number line, has to be greater than or equal to 1, less than or equal to negative 1. This value of x is not between two numbers, it's either one or the other. So writing it as a compound inequality like this is incorrect. You have to write it as an or statement by saying x is either greater than or equal to 1 or x is less than or equal to negative 1. Now here's how I remember that. It's silly, but this is the best way for me to remember it. When you have an inequality where the variable is on the left and you have a less than, to me this kind of looks like a D in the word and this kind of looks like an R in the word or. So less than or equal to is an and statement, or between. Greater than or equal to is an or statement, which is an or. So if I look at an example like this, absolute value of 3x minus 7 is less than or equal to 11. I know right off the bat that this is a and statement, and that my answer is going to be a compound inequality that's between. So I'm going to set up an inequality, 3x minus 7 less than or equal to 11. That's the positive case, and this is the negative case. And now I can solve it like I did in a previous lesson. Add 7 to all sides. 11 plus 7 is 18. We're left with 3x in the middle. Negative 11 plus 7 is 4. Negative 4. Now I divide everything by 3. My answer is that x is between negative 4/3 and 6, or x is less than or equal to 6 and greater than or equal to negative 4/3. That's an and statement with an inequality and absolute value. In this example, I have greater than 3. I know that's an or statement. So I'm going to end up with an answer that says x is greater than something or x is less than something. So instead of setting up a compound inequality in one long statement, I'm going to set up two statements. That 5x plus 2 is greater than 3, or 5x plus 2 is less than negative 3. And then I solve each one. I subtract 2 from both sides. I get 5x greater than 1. Divide both sides by 5. I get x is greater than 1/5. Or subtract 2 from both sides. 5x is less than negative 5. Divide both sides by 5. X is less than negative 1. My solution is that x is greater than 1/5, or x is less than negative 1. Okay, I had one more example to show you, but I'm going to stop right there. We're going to call it good with this last example and let you practice those in the assignment.